So there are lots of different types of matter, and one of the things that scientists do to deal with all of the information that we find is we try to organize the information. We categorize and we classify things. So it's a little bit like playing with Lego bricks and trying to sort them out so that you can find the pieces you want. You could sort them in many different ways, right? You could sort them by color. It's like, let's put all the blue ones over here and the red ones over there. You could sort them by shapes. Here's all the 2x4 rectangular bricks, and here's the 2x2 square bricks. Or you could sort them by what set they came from. There's all kinds of different ways you could organize that. The same thing goes with like shoes or clothes or chemicals in the garage, anything like that. So we sort matter. One of the ways we can classify or sort matter is by its physical state. So the three common states of matter are solid, liquid, and gas. One of our very common, very necessary for life substances is water. And we are familiar with water in all three of these states. When water is in the solid state, we call it ice. When water is in the liquid state, we call it just water. And in the gas state, we call it steam or mist or humidity. There is water present in the air in this room. Not a lot, but there is some. And so this illustration shows us how the particles are arranged in these three different states of matter. In solid matter, the atoms or molecules are close to each other. You might say touchingly close. And they are in fixed locations. They do move, but they don't move relative to each other. They may vibrate or oscillate, but they don't move around. And because of that, solids have a rigid or a fixed shape and a fixed volume. So I also have an analogy of this with students. Right now, this class of students all sitting in their nice little rows at their desks, you are in the solid state. You're not moving relative to each other. The person on your left was on your left 5 minutes ago, and 5 minutes from now, they'll probably still be sitting there to your left. Is everyone perfectly still? No. Everyone is at least breathing, I'm pretty sure. Some of you fidget, bounce your leg, whatever, that's fine. You're moving a little bit. And that's what atoms or molecules in the solid state do. They vibrate, they oscillate, they wiggle around. But they don't move relative to each other. We can further classify solids by how those particles are arranged relative to each other. We can have a crystalline solid or an amorphous solid. In a crystalline solid, we have some sort of a repeating pattern of how the atoms or molecules are arranged in three-dimensional space. In an amorphous solid, there's no long-range order. It's just kind of a big jumble. So looking at the classroom, are you guys crystalline or amorphous? You're crystalline because the desks are in rows. There's a pattern, there's an order to how you are arranged. Amorphous solid would be a lot like, kindergartners sitting on the rug at circle time, right? They're not necessarily sitting in a circle around the teacher, they're just all kind of just jumbled up on the rug. But they're sitting and fidgeting. Okay? In the liquid state, the atoms or molecules are still close together, but now they can move relative to each other and slide around. So for students, the liquid state would be equivalent to lab. When we are in lab, we are still in close quarters. We're close to each other, but now everybody's moving around. You need to get up and weigh something. Somebody else needs to go get a beaker, and we're moving around. That's what liquids do. Still touchingly close, but moving around relative to each other. So liquids have a fixed volume. Because the atoms are really close together, you can't really make them any closer. But the shape of the liquid can change. You take some water and you pour it from a tall, skinny cup into a bowl. The shape of the water changes, but the volume doesn't. In the gas state, the atoms or molecules are separated far apart from each other. The gas state for students is when class is over and everybody goes off in all kinds of different directions to their houses or their jobs or whatever. far apart from each other, moving independently of each other, but lots of space in between. Because there's so much space between the atoms or molecules in a gas, they can be compressed, and so the volume of the gas is changeable. So if we look at a liquid inside of a piston, so this is a cylindrical container with a lid that can move up and down. And we press this down so there's no empty space above the liquid, and you push on that. You can't compress the liquid because the particles are already touching each other. They can't get any closer together. If you put a gas in the same sort of a container, there's a lot of empty space between the particles. So if you push on the piston, you can squeeze the gas molecules closer together. Gases are compressible. So gas volumes will change. Gases change their volume, and they also change their shape. So they always take on the shape and the volume of their containers. They're a little bit like, you've heard any task that you need to do tends to take up all the time that you have available to do it. Well, a gas will take up all the space that there is in a container. It'll expand to fill the container. So this table gives us a summary of the different properties in terms of how the atoms or molecules are moving, whether they're just moving in a fixed position or they're moving relative to each other as they are in gases and liquids. The spacing close together for solids and liquids, far apart for a gas. And these directly impact the shape, the volume, and the compressibility of the different states. Any questions?